Assalamu alaikum dear students, I hope you all are good. Today we are starting our next topic, that is the discovery of enzymes. So let me tell you, there are three scientists who play the major role in the discovery of enzymes. Number one, it was Louis Pasteur, who found in his experiment of fermentation that certain substances were responsible to carry out the fermentation reactions, and he called those substances as ferments. Fine, we call these ferments as enzymes today, but Louis Pasteur called them as ferments. So he was the first scientist to see that certain substances were responsible to carry out the reactions. Number second, it was Edward Buchner. Edward Buchner, what he did, he actually isolated the substance from the yeast. He actually isolated the enzymes. Edward Buchner was the first scientist who isolated the substance from the yeast. And then third was Kuhne. Edward Buchner didn't name it, but Kuhne was the scientist who gave the term enzyme, which actually means in yeast, because it was extracted from the yeast. Fine, so these are the three scientists who play major role in the discovery of the enzyme. So next our topic is what enzyme does actually. I have already told you that enzyme is a biocatalyst which can enhance or decrease the rate of, it can either increase the rate of the reaction or either decrease the rate of the reaction. Earlier it was considered that an enzyme only increases the rate of reaction, but later the term was changed and it was called as a biocatalyst. It can go in either way. It can increase the rate of a reaction or decrease the rate of a reaction. So here I have chosen an example. If you see carbon dioxide plus water, they combine, and what they do, without an enzyme they form carbonic acid, H2CO3. What they do, they form carbonic acid. Without an enzyme, 200 molecules of carbonic acid are synthesized or produced per hour. Fine, 200 molecules of carbonic acid are produced per hour. Now, if we take this reaction in the presence of an enzyme, carbonic anhydrase, fine, if the reaction is catalyzed by this enzyme, which is carbonic anhydrase, the same reaction produces carbonic acid, but here the number of the molecules is 6 lakh, and that too per second. So you can see how many times there is the difference in the rate of the reaction, how many times the rate of the reaction has been enhanced. So carbonic anhydrase is actually the fastest enzyme. So here 6 lakh molecules of carbonic acid are produced per second. So this is how the enzymes increase the rate of the reaction. So we'll be studying what an enzyme actually does, what it does that the reaction is enhanced so much. So for the sake of understanding, I have chosen here, let me tell you, these are the substrate molecules upon which the enzymes act. These are the substrate molecules, and these numbers I have written here, for every reaction to take place, these substrate molecules, you might have read in your chemistry classes that these substrate molecules have to collide with each other. When they collide with each other, then only they will produce a product. Then only they will form a product. So I have written here activation energy here, the energy which is required to carry out the reaction. Fine, I have written their activation energy in the form of these numbers. Some have 2, some have 6, some have 9, some have 3, so on and so forth. Fine, so this is the activation energy, is the energy required to carry out the reaction. Fine. So let me tell you, in the absence of an enzyme, for example, first of all, let me tell you, the minimum activation energy required is 5. Only those molecules which have the activation energy 5 or more than 5, like it has 6, it has 9, can form a product. Here, this can form a product, this can form a product, this can form a product. And the molecules which have the activation energy less than 5 cannot form the product. So it's an example. Here let me show you three molecules. Here three molecules will form the product only. Here this will form, this will form, this will form. So I have written here three molecules form a product, and the rest of the molecules will not collide. They will not form the product because their activation energy is less than 5. So what happens? What an enzyme does? Say for example, this is an enzyme here. The molecules will bind at the active site of this enzyme. Say for example, these molecules have bound at the active site of the enzymes, and what they do, they come closer. After binding with the enzyme, they come closer with each other so that they can form a bond. So here what the enzyme does, it lowers the activation energy. So here the activation energy is brought down to 2 now. So all these molecules will be able to form the product. So in presence of the enzyme, all the reactant molecules will form a product. So let me tell you once again, these substrate molecules have the activation energy less than 5, will not form a product in the absence of the enzyme, and when the enzyme is there, these molecules will bind at the active site of the enzyme, fine, and they will come closer. After binding at the activation site of the enzyme, they come closer and hence can form a bond. And what an enzyme does in this process, it lowers the activation energy. Here in this example, activation energy is brought down to 2. Fine. So all reactants will be able to form a product now. So this is the job of an enzyme in a reaction. It lowers the activation energy. So here please have a look at this graph. Here I have chosen energy and reaction again is x-axis and energy again is y-axis. So if I have reactants, what they do, they have to form products. So with enzyme, this is the activation energy in presence of the enzyme. Activation energy with enzyme. You can see here it is, and without an enzyme you can see how much the activation energy had got raised. This is the difference between the two activation energies. So this is the activation energy with enzyme and this is the activation energy without enzyme. Fine. So a molecule is so reactants are able to, all those molecules which have less activation energy can also form products in presence of an enzyme. So I hope this is clear to you how an enzyme works. So tomorrow we'll be studying lock and key hypothesis. Fine. So we will be studying the models of the enzyme action tomorrow. So I hope this is clear, and if there are any questions, please let me know in the comments. Thank you so much. Stay blessed, stay safe.